Alright, so today we'll do review on the first chapter, okay? And then tomorrow on second. On Friday we have a test. So let's do review together. You tell me what we have done in the first chapter, okay? And try to recover. So in the first chapter we study vectors, right? I think I don't have to remind you about vectors, about formula, right? About distance between two vectors, something like that. But the very important thing is you can look at a vector as a number, right? As a point, okay? So you have some vector, you have point. For vectors or for points, you need distance, right? You need distance. For them, you need distance because we need distance to measure. Because without distance, we cannot do anything. So we need distance. Distance between two vectors, or I will consider only in R3, right? Because in R2, that is special case. X1, Y1, Z1, and then the distance between this guy X2, Y2, Z2. All right, just that. What else? If you have two vectors, right? What do we want to know about it? We have two vectors. So we want to know about
angle.
Angle, right? About angle. Do you remember the formula of angles of between two vectors? So we have cosinus law, right? So I have some kind of cosine of theta. That is the angle between two vectors is equal to u and v divided by normal of u times normal of v, right? So where now u and v, we know that is in Euclidean space. And u times v is just dot product, right? What is dot product?
What do you mean?
Dot product.
It's you take the coordinate.
For example, you have two vectors x1, y1, z1, x2, y2, z2. So dot product of this vector and this vector is just sum of products, right?
Yes.
Of corresponding entries. So it's dot product. I don't have to remind you about it, okay? So we have this angle. In case,
Thank you.
you have one question like that on final exam. So you just use this formula, right, to find dot product and then norm of u and v and just plot everything in here. And then in order to find this angle, you just apply the cosine, right? A cosine to this. So theta is equal to a cosine uv u. So basically, you can apply that formula directly. Okay. So we have for the first chapter we have 4 problems. So I just go ahead to solve those problems, right? In here for each topic. So let's say u is 1, 0, and 93, and v is 2, 98, and 1. So they ask you to find angle between the vectors in radians and degrees. Apply this formula. I have theta is equal to a cosine. Dot product of u and v 1, 2, 0, 98, and 93, 1. So I get 2 minus 3, right? Over the norm of this guy is square root of 10 because 1 square plus 9 square is 10. And the norm of this guy is 4 square. So 4, 64, right? So I have 68 and 1, and have 69. Is it? So you get negative on the top, negative 1 on the top, and here you get this, and then you use calculator to find this angle. So usually calculator will give you some answer in radian, right? Radian, but that's good. So this question is almost free. Okay. What is the next in this chapter? What's the next? If you have two vectors, right? You are interested in the angle, and you are supposed. What else? Projection, right? Orthogonal projection. Another guy is orthogonal. Orthogonal projection of one onto another. Of one onto another. So the formula is projection of u onto v is equal to uv over v square and then times v, right? Because that is orthogonal projection on vector v. Orthogonal projections, are very important, right? We have seen that. And they have us to find distance. And in this practice exam, we have at least 2-3 problems on that, like that, or on orthogonal projection. Okay. So here's the problem. You have negative 1 and 1, and then your v is 9, 0, and 9. Let's find orthogonal projection of u onto v. Right? Of u onto v. That is the first question. The second question is find the vector component of u orthogonal to v. Okay, so let's find projection of u onto v. Applying that formula, we have dot product between these two guys is 9 minus 0 plus 9, right? Over norm of v is 9, 9. So you have 81, 81, 2 times, that is 162, right? 162. And then multiply by 9, 0, and 9. So let's simplify that. Here you have 18, 2 with 2 will cancel out, so you get 81 in here, and simplify by 9, you get 1, 9, right? You get 1, 9 with 9, 0, 9, so basically you get 1, 0, and 1. It's very beautiful, right? That's good. Now let's consider component of u orthogonal to v. What's that? So you see, if you have vector, this is your vector u, right? This is your vector v. Okay? So here is orthogonal projection of u onto v. Okay? And this vector u, has another component. This is component, right, of u onto v. But at the same time, u has another component on here, right? Where that guy is orthogonal to the v. So basically, that's why you need this one, right? They ask you to find this vector. So this vector is important. Actually, the length of this vector is the distance, right, from this point to this straight line. And we use that in the next couple of examples to find distance from one point to a straight line, one point to a plane. Okay. But what is this? That is just u minus projection of u, right, onto v. So basically, once you get 1, 0, and 1 in here, and that component is equal to, I will say, that is w equal to u minus projection of u onto v. So just plug everything to 5, and you get 0. I'm running short because 1 with 1 will be cancelled out, 1 with 1 will be cancelled out, negative 1 and 0. Okay? So the first two questions, are easy. Makes sense? Just very, very elementary computation. Next, Yes, we know projection, and now let's consider straight lines. Straight line. Straight line. Straight lines in the space, right? So in the plane, okay, that's not a big deal. In the space, we have two forms of equation of straight lines, right? The first form is what? Is parametric, and the second one is canonical form, right? But basically, the straight line, what is straight line? In order to get a straight line, you need one vector, right? We call direction vector, and one point. Let's say A, x0, y0, and z0. Direction vector A, okay? So if you have one direction vector, A in here, and then you have one point, x0, y0, and z0, so that is your straight line. The straight line passing through that point, right? Passing through that point, okay? And has direction vector A. So how to write the equation? If you pick any point here, x, y, and z, right? So your vector ax is parallel to this vector. That means, you know, they are scalar multiple of each other, okay? So I write the equation of straight line is ax equal to k, or sometimes just write ta, okay? Ta, where a is a1, a2, a3. So if you realize this equation, you expand this equation, you get x minus x0, y minus y0, z minus z0 equal to k, a1, a2, a3. See that? So from here we have two forms of equations. The first form is canonical. Canonical is, you know, if you set, you know, three entries, right? So here from here you get three equations, right? You get three equations. So first, x minus 0 equal to ka1, y minus y0 equal to ka2, z minus z0 equal to ka3, okay? And you solve for the k, you get x minus x0 over a1 equal to y minus y0 over a2 equal to z minus z0 equal to a3. And this is canonical form of our straight line. Okay? Another form of straight line is this. So you write just equation like, okay, I write here, so you have x equal to ka1 plus x0. You see, you put x minus x0 equal to ka1, right? So from that you get x equal to ka1 plus x0. And then you have y equal to ka2 plus y0, and then z equal to ka3 plus z0. Yeah, it's about straight line. So in this practice exam, they ask you to find an equation of a straight line passing through the point -a, -7, 3, and perpendicular to the xz plane. So you have a point that is a, -7, and 3, and direction vector. You know, this straight line is passing through that point perpendicular to xyz plane. So what is direction vector of this straight line? Xyz, suppose xyz plane is this, right? Plane is this. And that is perpendicular, right? So what is the direction vector? It should be y-a6, right?
0, 1, 0.
Yeah, should be 0, 1, 0. Because all, you know, perpendicular straight lines with z, x o z would be parallel to y-a6, right? And you can take y-a6, that's it. Make sense?
So it's, you said it's perpendicular
Yeah,
to the
to the XOZ space, XOZ plane. So if that is perpendicular to XOZ plane, the straight line is perpendicular to XOZ plane. You know, from here we can get A just, you know, 0, 1, 0. it should parallel to y axis, right? To y axis. So you have straight line, you have point, you have a direction vector. You can write the equation, and of course, please, you have two forms of this. It just asks you to write down.
And if there's perpendicular line is parallel, how would that be? The vector. Instead of perpendicular, if the line is parallel.
If the line is parallel, there's no way to determine that, because you have a plane in here, right? And you have infinitely many lines parallel to that. So when we define planes, we also need one perpendicular, one normal vector, right? That's enough. But for straight line, we need direction vector and one vector. Okay. Next question is about the plane, right? So we have straight line over there, and now we have a plane in space. So how to determine, right, equation of a plane in space? As I just mentioned, we have plane in here, and that plane passing through one point, right? For plane we need normal vector. We need normal vector. We don't need directional. If if we can define a plane using two straight lines, right? Two straight lines, because two straight lines will form something in here, right? Is that correct? If you have two straight lines, so you can make that, and you have one point, you can determine the plane, right? But two straight lines, if you use cross product, so if you have two straight lines, you can determine the normal vector, right? Which is perpendicular to those straight lines. Make sense? So and thanks to that, you can determine the equation of the plane. So basically, if you have normal vector, n is n1, n2, and n3, and you have a point a, x0, y0, and z0. So you can write, yes, that is ax perpendicular to n, right? Ax perpendicular to n means that dot product is 0. And this is equivalent to that. Ax dot product with n is equal to 0. So from here, you see, Ax is scalar multiple of direction vector. In this case, dot product is 0, so I can write, that is n1 x minus x0 plus n2 y minus y0 plus n3 z minus z0 equal to 0. And that is general equation of a plane. The fourth example in practice exam is to find the equation of the plane with the given characteristics. The plane passed through 3 points. Okay, so we need to write the equation of the plane from these 3 points: -2, -4, and 3, -2, 4, and 1, and then 1 and 1 and -3. So that they don't give us any normal vector, but that's okay. We have to find that. As I mentioned previously in here, right? So if you have two vectors, you can find the perpendicular. That is called cross product. So we have 3 points, we can find two vectors. Let's write out two vectors, right? The first vector would be u equal to 0, 8, and -2, okay? That is the first vector. So you say, you take this guy, A, B, and C. So say, the first is AB. And then you can find AC. So AC is this. So you get 3, 5, and -6. Yeah, you don't need U in this case. Okay? Agree? So once you have two vectors, you can find their cross product. So the cross product of AC, AB and AC, cross product of AB and AC, that is IJK, and then 0, A, -2, and then 3, 5, -6. So I hope you still remember this determinant, right? So we expand along the first row, and then we get this. Yeah, let me finish that and I'll tell you the shorter way to solve this. Shorter way to solve this. So if we have I, right, what is I? So 6, let's say A, 92, 5, and 96, plus J, so 0, 92, 3, 96, and then K, 0, 8, 3, and 5, right? But here is negative, here is plus. Here is negative because the position of G is 1, 2, right? 1, 2 is off. So that's why we have this negative. So you multiply, you find determinant of each in here. So you have, coordinates of that normal vector. Okay? Coordinate of that normal vector. And you apply that to this equation. To this equation, and you are done. But basically, you can solve that shorter, faster. Instead of I, J, K, do you remember that or not? Instead of I, J, K, I can apply X, Y, Z. How about that? We have condition, how to use determinant to check if 3 points are coplane or not. Do you remember that? So if 3 points are coplane, so determinant should be equal to 0. Get it or not? Okay.
Basically, there's a plane that like went through every 3 points.
Yeah, the plane passes through 3 points. So yeah, and that we have a third vector. Yeah, okay, I agree. So let's find these 3 vectors and then plug into that equation. you find the equation of the plane. Okay, so I will not solve this. It's just simple computation. So here we remind about the cross product, right? Cross product. We have another problem, how to find distance from one point to a plane. Distance from one point to plane. That is the 5th question. You have A, 3, 94, and 2, and then you have plane 2x minus y plus 5z equal to 10. And we need to find the distance from that point to a plane. Okay? So in case, of course, I asked you to do a formula sheet for you, right? But in case, if you don't remember how to make that, how to find the distance. So if you have a plane like here, right? And here's your normal vector, is that correct? So if you have some point in here, you need to find projection of that point onto the plane, right? And this is the distance, is that correct? Right? But that point, you can find projection of this. This is the point, so we can consider like a vector, right? So if you, for example, you connect this one with this guy together, but we have to be very careful in this case. And then find projection of this guy onto normal vector, right? So that is the distance. The distance is norm of the projection. Make sense? But we have to be very careful because I think I did that mistakes before. Usually we have to pick a point on the normal vector. On the normal vector. Otherwise we get wrong. Make sense? Because if you consider this point line vector, right? So that is not vector, not this vector. Are the vector between this point and the origin. Get it or not? Between that point and the origin. So if you project this vector onto n, you get a wrong answer. You will not get the distance. Can you get that or not? We have to pick the point here, right? And then consider the difference. Consider this vector and then find projection of this vector onto that normal vector. And the norm is the distance, otherwise it's not correct. Anyway, I think we have some formula from here, right? We need to find, as I said, the distance is equal to norm of projection of PQ on the norm. Please find me PQ and N in this case.
N is 2 negative 1 5.
N is 2 negative 1 5. Yeah. And this is A, right? Okay, let's say this is P. So how about Q?
Q is 0 0 2.
Okay, if you pick any point like here, again, I just want to tell you mistakes, right? If you pick some point right here, right? Okay, and here's your vector, right? PQ. And can you project that vector onto this? Yes or no? You have to shift them so that they will be on the same plane. You cannot find projection of one vector onto another like this. Make sense? So see, when we consider projection of two vectors, right? So we suppose that they start from the origin. Make sense? So that's why we can find projection of one onto another. But in this case, so how to pick Q? Okay, P is this. How to pick Q?
Is any point in the plane, right?
Yeah. Let's pick any point on the plane.
0 0 2.
0 0 2. Okay. 0 0 2. And then you find. Okay, let's say that's Q. Then you find PQ equal to -3, 4, and 0. And from here you find projection and take the norm. No, my question is, suppose, that is your perpendicular plane, right? Okay, that is your normal vector, okay? So normal vector, any vector like this, parallel to this is normal vector. And here's my point, right? Here's the point. And I fix that point, right? I connect this guy to this guy, you see? Something like this. Can we find projection of this vector onto this normal? That's my issue. Get it or not? So you have formula, but how to use that formula? The issue is, yes, I have these two vectors, right? How to find projection of this guy onto this guy? If they don't start from the one, if they don't start at the same point. If they looks like this, I'm good. Get it or not? But if they locate like this, how to apply the formula? There's no way to apply that formula. Right? So if you copy that formula from textbook, you have to understand how to find Q. Remember that. Do you have formula sheet? I think you should have the formula sheet, but how to use that? Yeah, we still have one more problem, so we have plenty of time to discuss.
Is it the cross product? Is a cross product
Cross product?
of PQ?
Cross product of what?
PQU,
Hmm?
the norm?
Yeah, this is the norm. I mean, the norm of projection. As I told you, right? If we have this vector, this is P, this is Q, and you connect this, right? You connect this PQ, and you find projection of PQ onto the normal vector, you are good. Make sense? But no, how to in this case? And to be honest with you, I just told you that, yes, you have this, how to find a projection of one onto another. Get it? Is there any issue with that? So you pick some point here, right? Okay, let's say, what is negative 3, 4, and 0? X 0 in here, negative 3, and 4 in here, right? So this is a vector. Geometrically, you know, if you take this vector, yes, no, it's not good. But if you already have some negative 3, 4, and 0, that's good already. That is a point, right? In here. Is that correct? I just confused you. And how about n? Where's that? That is 2, negative 1, and 5. Where's that? That is a point, right? 2, x equal to 2, y equal to negative 1, and this is equal to 5. This is not a point here. So basically that is another point. So you already have two vectors. They should start from the origin. That's it.
Wait, n is a point?
A vector is a point.
But isn't it n the normal vector of the
Yes, yes.
Oh, okay.
You see, as I mentioned previously, if you have a point, you have a vector, right? If you have a vector, that is a point. Is that correct? Is that correct or not? So sometimes you have to be aware about that, right? I just try to give you a wrong picture in here. Get it? I gave you a wrong picture in here. Because physically, yeah, we cannot do that, right? But when you find vectors, basically they start from the origin already. Because we have coordinate, right? Get it? Agree? So from here you can just go ahead to apply that formula. Make sense or not?
So you do need to find a Q or you don't?
You just pick some point from the plan.
So that Q would be okay?
Yeah, it'll be okay.
What's another Q that would be okay?
Would be good. If you have another Q, you can find another one, another point. Wait. Now you confuse me. Now you confuse me. If you pick one Q, right? You have not that one. What happened if you pick another Q? Interesting. Wait. So this is your normal vector, and the point 3, negative 4, 2. Let's say 3, negative 4, 2 is this. 3, negative 4, and 2 is this. Right? And that is your P. Is that correct? And this is your normal vector. So you have to find projection of this guy, but it's no way to project this guy onto this. You have to find the Q over there, the Q on the plane, exactly the Q on the plane, and then you connect them. So you can apply that formula once you get the one point on the plane. Okay. Next one. We have another formula. How to find the distance from one point to a plane, to a straight line. But when I check the practice exam, I don't see that problem. I don't see that problem. So I see another problem is to find the area of triangle with the given vertices. So you have 3 points in here, and then B is 4, 0, and 6, and C is -2 and 1 and 0. From here you need to find area. Who remember the formula? What's that?
The cross product AB.
So that is the norm of the cross product, right? That is the norm of the cross product. So you have 2 vectors in here, and you need to find the area of this guy. This should not be a norm, should be a half of the norm, because the norm of that guy, that of the cross product between these two is the area of parallelogram. So the norm of this triangle is the half of, the area of this triangle is the half of the norm of the cross product. So basically, if you have 2 U and V, you take cross product, and then you apply the norm, you divide by 2, you get the area. That's it. Okay. So I expect that for this problem, you might spend maybe just 2-3 minutes. 2-3 minutes. Make sense? Just find y determinant.
So U cross product B is, U cross product V is basically your AB cross product AC.
you can apply AB, AC, or whatever you
Okay.
want. Yeah. There's any way if you make like this, again they have the same area. It's not big. Let me see, we have something else in here. All right, and we still have another topic in this chapter. Is about surface, right? I plan to make copy for you, but I just forgot my phone number, my office phone number, so I cannot use the printer. So, but we will not have a question on that. So basically, just you want just have a look at that. So we have different kinds of surface. We have cone, right? We have paraboloid. We have some kind of, so. To be honest with you, I don't remember the name. But, and I think we spent some time to discuss about this, right? Discuss about this. They are almost the same with different direction. Ellipsoid, sphere, and then we have cone, right? Something like that. So we will not have that. So don't care too much about it. Basically, you have 4 chapters, so 6 questions on each chapter. So that is my plan. 6 questions on each chapter.
That's for the final, right?
Yeah, that is for the final. Okay, I will not start new. Maybe I will do that tomorrow. Okay? Have any question? So basically, you have 6 questions for this, but you have formulas, right? So you can do that real quick. Again, right? Strategy of the final exam is this. So you have 2 hours, right? You should not spend 30 minutes for each chapter. For the first chapter, maybe you spend only 20 or 15 minutes. So spend more time on the last chapter.
And there's a review on webassign.
Ah,
you said?
yes,
Say?
yes, yes, yes,
Okay.
yes, yes. And so we do tomorrow, and then we have 12 questions, on the test on Friday. Okay?